post. Hey everybody, welcome to another edition of Gruber Wired. I'm Mark Beach.
I'm John Dotson, and that little clip, if you happen to know what movie that came from, let us know.
Yeah.
Maybe you can guess what that came from.
Yes.
Right?
I guess so.
We'll keep it a mystery.
Yeah, it's a mystery.
It's a mystery.
Hey, happy new Pope Day.
Oh, yes, that's true. We just had new Pope today,
It's
didn't
an
we?
American Pope.
Yes. First North American Pope ever.
Yes.
Yeah, very cool.
USA, USA, USA.
So lots of fun stuff going on, though, right?
Yeah. It's getting hot. Going to be 105 on Sunday. Happy Mother's Day to everybody out there. If you're a mother.
Of course. Happy Mother's Day, Mom. So, yeah, lots of stuff going on. But that first little video clip is kind of just a brief introduction to that sci-fi world that we're going to be talking about today and what's becoming reality, correct?
Right, yeah. And everybody stay tuned because we're going to talk about organoids, right?
Yep, Organoid Intelligence.
Organoid Intelligence and the ethics behind it, the technology behind it, how far they've come thus far, and, weigh in. This is a pretty fascinating topic.
It is, and if you want to show that video number one, let's just start off with this, and what is Organoid Intelligence?
Yes. Think Android, only organoid. So they call this OI or OI.
OI. It's OI. And what really,
not AI. Yeah.
And really what it is an emerging field that explores the use of brain cells, correct?
Right.
And we're using those to build biocomputers.
Now they're finding that this has a lot of potential as far as lower energy use, faster learning curves. It turns out God kind of knew what he was doing when he made our brains to begin
Right.
with. So we're just trying to reverse engineer that, it seems like.
That's really what we're doing. Is we're reverse engineering our brain capacity and what it takes to generate these cells and what we know, correct? As far as learning goes and using them in the computer world. Now, we've already used, cells that we're aware of to replicate, endangered species, right?
Right.
And that works with organic materials.
Yeah.
But what we're talking about here is taking brain cells and using them in composite materials and using them alongside, computer chips.
Yeah.
And working in conjunction with them.
Yeah, pretty crazy. Which, one of the things that we're going to show is that they actually used it to learn Pong.
Correct, yeah. Remember that Pong off the Atari?
Right,
Yeah.
and where it took AI about 5,000 repetitions to get it, it took the Organoid Intelligence 15 tries before it learned it.
Yeah. So, in conjunction, this is
pretty
crazy.
insane.
Yeah.
Your mom says thank you, by the way.
Yes, you're welcome, Mom. Love you much. Hey, Mom just had a birthday, too, so I might as well go back and say happy belated birthday, Mom.
Happy birthday.
So that's great. They're doing well up there.
Yeah.
Yeah, we're going to go visit them in July. We're going to go up there to Washington and spend some time with them and the family.
That's awesome.
Yeah, we're looking forward to that. It's going to be great.
Very cool. So,
Gonna be great.
So, Don Johnson.
Here we go again.
Oh, man.
I've yet to find out who this Don Johnson is. Somebody playing on my name there, and I just don't know who it is yet. I'm going to find the culprit.
Maybe it's Noah.
I was thinking Noah for a moment.
It's a little brainy, so it could be him.
Yeah, it could be. So we'll see.
Yep. So, the point that I made to you when we started talking about this was, so what happens when you put AI on OI? do you have a living thing at that point?
Yeah, that's what we're going to get into here in a little bit. It's like, where does that line cross?
Right.
Where do we take a look at living organisms? But at the same time, too, you got to stop and think. Everything around us is living in some aspect. Everything uses cells, even the pens that we carry. So how far do you go down in the basic building blocks to realize, okay, we're going to combine cellular structure along with computing ability and come up with a actual computer.
Right.
And then where can it go from there? Can it learn to grow on its own, learn on its own? And does it take it to different levels that we weren't thinking about?
Right. Exactly. And, the article that we read talks about scientists cultivating brain organoids from stem cells, enabling them to form neural networks similar to those of a human brain, which is nuts.
It is wild.
And then AI-driven techniques help them learn.
Correct. Because AI doesn't use this type of interface, right?
Right.
So what they're able to do with this is take AI, combine it with, these OIs. So now you have working in conjunction with one and another. Do those simulations grow together?
Right.
That's to be determined. I mean, this is kind of the new territory. This isn't something that's like, wow, it's all over the place. This is very, very new.
Right. But but it's been around for a little bit. I mean, since the early 2020s for sure, and because they've already taught their little prototype how to play Pong.
Yeah. That's just crazy, isn't it?
Yeah.
But there's so much going on here, biohybrid computing, exploring how I can't even say that word. Organoids can serve as biological hardware, potentially offering more efficient computing than silicon-based systems.
Right.
So, wow, it's a lot in one sentence, but there's a lot going on there.
Yeah, I wonder, obviously energy usage would be way lower.
Correct.
And therefore heat would be less of a byproduct, but I wonder if they have to keep it gooey.
That's a good question. I didn't do too much research on that to see. Does it? Well, that's we got to stop and think a second. Our brains are contained in a fluid, in a mass. So, what type of biological material is needed for that stabilization to stay there?
Right.
What type of environment?
Kind of biogel or something.
But medical research. This is going to be one that's going to be huge. Like they were saying in the video there briefly, Alzheimer's. Dementia. I mean, there's a lot of medical research that could be done using this particular capability.
Yeah, we've covered a lot of different subjects over the last year and a half, but this one's really like top of the game.
Yeah.
It's fascinating.
Well, I'm curious how far this goes. Will it go in the future as far as, like for our industry, working with cabling?
Right.
Right now we went from using a solid copper state, wire to conduct, electricity over, to using a light source for fiber. Is there going to be a point in time where we use a transfer of cells?
Well, we talked about in one of our previous podcasts about like self-healing cables and self-healing chips, materials, things like that. That if they got damaged, they had ways to work around, where they were damaged.
Correct. Yeah.
So it's you start taking this as a whole picture, and you can kind of just see what's coming down the road. Robots that are using human brain cells powered by AI or trained by AI
can self-heal if there's an issue.
Yep.
Physically.
Right. So what are we really building here?
I don't know. Are we on the verge of playing God? I mean, depends on how you look at it, right?
Is it alive?
Hey, as long as you don't grab the abnormal brain, we'll be okay, right?
What's the abnormal? What do you mean?
Dr. Frankenstein?
Oh, right.
Grab the abnormal brain. Hey, Don Jotson up there says, does that make her my mother too?
In the mirror universe.
Yeah, right? Could be my wife, for all I know, that's coming in, chiming into that, but I don't know. So we'll have to wait and see.
Hey, where's that question coming in over? Is it coming in? It's not, obviously not in our feed. So where's that coming from?
I don't know.
TikTok.
So that's a TikTok person. Okay.
All right.
Interesting. Okay, TikTok. I'll find you. I don't know who it is, but I'll find you.
All
then
right.
I'll go Liam Neeson on you.
So we have another video to see, right?
Oh, we got a few to take a look at here. If you want to pull up video number 3, we'll get into some ethical overviews and overtones of this particular topic. There you go.
Yeah.
Field that involves growing mini brains from human stem cells has the potential to revolutionize our understanding of the human brain and lead to new therapies for neurological diseases. However, it presents a significant ethical quandary, as the possibility of creating conscious entities and the potential for misuse could lead us down a path reminiscent of
Right.
the dystopian future depicted in the Terminator movie franchise. Skynet could be closer than we think. Organoid Intelligence holds immense potential for the medical community, providing a
There's only one
significant
person
leap
watching.
forward in neuroscience research. These mini brains can offer valuable insights into the development of neurological diseases such as Alzheimer's and Parkinson's. Moreover, they can be used to test potential therapies and drugs for these conditions in a more efficient and ethical manner. One of the most significant concerns regarding organoid intelligence is the potential of creating conscious entities. As these mini brains grow and develop, they could become conscious, raising ethical questions about their treatment and the responsibility of their creators, us. If they are conscious, should they have rights like humans? Are we creating life without
Right.
fully understanding the consequences of our actions? This possibility of creating conscious entities in a lab is eerily reminiscent of the plot of the Terminator movie franchise. In the films, machines become self-aware and rebel against humanity, leading to a dystopian future where humans are subjugated by machines. Look at the opening shot of Terminator, machines just stomping all over human skulls. Is that going to be us? Although organoid intelligence is not the same as machine intelligence, the creation of conscious entities raises similar ethical questions about the rights of these entities. If we create something and it's conscious, does that mean it has rights? Yet another concern regarding organoid intelligence is the potential for creating enhanced intelligence. As these mini brains are designed to mimic the structure and function of the human brain, there is a possibility that they could develop superior intelligence, surpassing human intelligence in some areas. This could lead to a range of ethical issues, including the creation of beings that are more intelligent than humans and potentially uncontrollable. This ultimately could lead to our downfall, which would ultimately lead to them taking over the world and the end of the human race as we know it. Moreover, the misuse of organoid intelligence for unethical purposes is also a significant concern. The creation of these entities could be used to create super soldiers, manipulate human behavior, and create intelligent machines that could be used to control and manipulate people. The risk of misuse in the wrong hands is too severe to ignore. While the field holds immense potential for medical research and treatments, the ethical implications of creating conscious entities and the potential for misuse must be carefully considered. We must establish a framework for the creation and treatment of these entities to ensure they are protected and used ethically. But honestly, if we've already started making these things, it's just a matter of time before they take over. As we continue to develop this technology, it is essential to remember the lessons of the Terminator movies and approach this technology with caution, as the potential consequences of its misuse are too dire to ignore.
Okay, so the ethical question.
It feels eerily like iRobot a little bit
a
there.
little bit there, huh?
Yeah.
No, but there's going to be a lot of things with this, and the ethical question is, like I said in there, is it possible that we could see in the future with this technology that consciousness could become a thing?
Yeah, I mean, you know, it's kind of like playing at the Wuhan lab with the gain of function research, I think.
Right.
We're not quite sure what's going to come of this, right?
We don't know. But the one thing I do know is we don't even have a definition yet of what consciousness is. We're all self-aware. We know what it is, but there's not a scientific or any sort of definition of what that really is. So
Right.
at this point in time, how would you know when that actually took place?
Yeah.
You know, so that's one of the ethical questions there that will have to be answered.
Well, and because we're teaching it to basically mimic humans, then it's going to respond kind of like that, right?
Sure. Yeah.
So how do you know? You ask
don't.
it, are you alive? Yeah, I'm alive.
But is that just a generated response,
Right.
From the input that they've been given,
Yeah.
versus, an allocated response from a consciousness?
Now, while we're live, if you have any comments, feel free to share. We'll try and address them live.
But besides that, I think the scary part of that is, there's some people out there a little bit scared of this type of technology.
Sure.
And that's where you see the science fiction comes in with the Terminators and everything else like that. Like anything else, we always say there's some bad apples in this world. You're going to see some things take place that's wrong. We all understand that. But I think that the good that's going to come out of this is going to be tremendous.
Well, I don't think there's going to be any way to stop it, really. I mean, people are going to do it, like cloning and other things. People are going to do it whether, the powers that be approve it or not. If they'll find a way to do it as human capability continues to increase, it's just going to be something that is a natural evolution of science and technology, science meeting technology.
Sure.
So it's going to be more along the lines of how to control it as opposed to whether it should be allowed or not.
Yeah, and whether, looking at it as a point from a tool, right? TikTok, could I be OI John Dotson? I guess you could. We just don't know because I don't know who you are. Somebody's messing with me out there on TikTok, so it makes it fun.
You don't think it's Harry, do you?
Could be Harry. Doubt it, though.
Yeah.
Doubt it. No, but with this technology that's coming through, I could see the advancements, coming along pretty quick. I really do see that this is going to speed up all sorts of advancements in technology as we know it.
Right.
Especially with our industry and infrastructure, right? Designing not only new materials, but using the materials we have, to be able to push data faster rates, zero latency, the whole program.
Right.
That's all going to derive from a lot of this type of technology.
Right. And once they figure out how to work, brain cells with chips, are they going to put chips in your head?
We're already doing that.
To make,
look at Neuralink.
Well, yeah, but I mean, that's
when it becomes
basic.
more commonplace.
I'm talking about for processing.
Well, yeah, what's going to happen is one of these days, this will no longer exist.
Yeah.
It'll be an implant in your head somewhere on you. It'll be implanted. So you're just picking up a signal and processing it
Won't be
immediately.
Implanted in me.
No, it'll be after our lifetime for sure. But we're getting there. That's where they're going.
Yep. I hear you. One of these videos is the Pong one, right?
Oh, let's see here. I want to say it's video number 4 is the one about Pong that you wanted to take a look at.
And then we
bring that up.
And then we want to pull up that image that I sent you last after that one. Yep.
No, that's not the Pong one. Maybe it's number 3.
No, we did number 3. Maybe it's number 2.
Maybe it is number 2. We're taking a look at this for you. We'll get it going here. That's it, correct?
I don't know.
Well, show it and we'll find out.
Intelligence? Scientists have grown brain cells in a dish, connected them to a computer, and taught them to play Pong from scratch. These neurons, called brain organoids, were stimulated to form neural tissue, creating brainwave activity. Once connected to a virtual world, this dish brain learned to play Pong in just 10 to 15 simulations, which is much more energy efficient than traditional AI, which typically requires around 5,000 simulations. It demonstrates that neurons in vitro can perform goal-oriented tasks. This field, known as Organoid Intelligence, or OI, is opening doors to biocomputers that could store information and solve complex problems, potentially surpassing the limits of silicon computers. Stay tuned for more updates. By the way, did you know what is
Very cool. So yeah, if you want to bring up that other diagram that I had emailed, I was wondering, how does this look? And I actually got this from the website of the company that is actually building this.
Okay.
Right? So this is a diagram of of their working model, essentially. Do you have that, Cass?
Yeah, give me 1 second. Sorry.
That's okay. And so just describe it to you. It's, the chip, and within the chip itself, it shows both the silicon layers, or the hardware part of it, and then the neurons and the brain cells that are actually connecting everything, right? Pretty nifty.
Yeah,
Kinda
it's
like what we see
interesting,
behind us.
you know. Yeah, it's one of those things where you take the cells, and the cells are very adaptive. That's the one thing about the human brain, is it's very adaptive in all scenarios.
Right.
And it goes down to the molecular structure of those neurons that are in there.
Right.
I mean, that's the basis for who we are, is composited in that system. So
Right.
taking those neurons and understanding the very specific job that each neuron has to do. Okay, so they're able to go and collect this particular neuron to do one job. This is for another. Here's another one, in these cells. And then take those and implement them into the chips themselves. And that's where you get the computing factor that comes along.
Yeah, it's...
So my question again is, okay, if they discover... Oh, here we
There
go.
we go.
If they discover 10 of these neurons make consciousness, right? So that means we only give it 9, and it can never have consciousness, right?
Yeah, well... So yeah, and this, again, is directly from the company that's building this, that's built this Pong prototype. And this is the layout, the structure, and you can see the neurons are kind of just overlapping everything. And as the graphic says, neural activity changes in real time to minimize environmental unpredictability.
So just as we react in real time.
Right.
These computer simulations and models are acting in real time, where the neurons are actually exchanging that information instantaneously.
Right.
Pretty cool stuff. I mean, it's beyond my pay grade to understand how this works at that level, but
but the idea is, presenting the thoughts out here, and this is what we try and do. We try and stimulate everybody to think about all the different aspects that we have in play when we talk about AI. And there, we have an AI podcast with Gruber just for that stuff. But this OI is really superimposed over that. It's an overarching theme on AI, because AI is probably going to be incorporated using OI at some point.
Oh, I'm sure it will be. I mean, this will have to work in conjunction with one and another. I mean, it's going to be that way. They're going to have a symbiotic relationship.
Right. So you have, basically an application that is faster than the human brain when it comes to reasoning,
Sure.
Or it contains a lot more information. Let's put it that way. It might not be faster, but it has more information at the ready, recall. And then you have a brain cell structure, neurons, transmitting and transporting and calculating, the data.
Sure. And it makes sense. I mean, going this direction from what we know, right? What we know as human beings
Right.
is our brain function. We
Right.
know, we feel, we can understand, we can touch, we can smell. We have all of this sensory going on. And so when we're developing this technology, we're saying, hey, I already know what this sensory is. I know where I want it to be. How do we go from A to B to C down the line?
Right.
And studying those neurons and finding that out and capturing those particular particles that are designed to do a specific job within the brain to go inside and work with a specific type of computer, chip and idealisms, it just opens a whole new box.
Well, and think about it, so they have some kind of optics camera type of technology for eyes that then these sit behind it and process the information of the eyes of technology, right? And all that data is fed back through this structure to analyze situational awareness,
Sure.
right?
But I also see the benefits of this, like you were saying in the future, where you get a chip in your brain. Now, if all of a sudden, right, where I can take a look at a subject, I can do some reading. Now I got to sit and have that thought moment, right? That moment to persist, to come up with whatever I'm thinking of, an answer, a solution, whatever it might be. But to know that, in the future, hey, we can plug this chip in your brain, right? And instantaneous answer. No more thought process. It just comes right to you.
Well, there are people who do have that instant recall. They have
Christopher Such over here.
Photographic memory, right?
Just talk to Christopher Such on our sales team. That guy's got one of the best photographic memories I think I've ever seen.
Yeah, and there are people who have phenomenal abilities. Even they. With people with autism that are on some kind of spectrum, but they're highly functioning in certain areas. So whether it's music or mathematics, they can be highly functioning in certain areas. And you think about having the ability to do something like this natively just by a little bit of an addition and a software upgrade.
Yeah. Hey, why not upgrade ourselves? But taking a step further with what I know that some of those people out there, like Elon Musk and so forth, they want to get to a point in time where they can discover what brain consciousness is and be able to say, okay, I can take your conscience, upload it into a system, and then return it. You can be in two places at once. We've talked about this before, sitting here in Phoenix and all of a sudden being able to upload your conscience to a computer, send it to Japan for a board meeting, okay? Have your board meeting, and then come back. I mean, that's stuff people are talking about.
Yeah.
It's out there.
Yeah,
but this is kind of a step towards that.
Right. And, building biotech really is redefined by this type of stuff.
Yeah.
Because you're talking about things that everybody incorporates in their daily lives, technology, whether it's computers or any other kind of tech, and then how it gets there and the efficiency that the human brain already possesses, and leveraging that into tech as part of it. So it blows my mind. When we came across this is kind of like more mind blowing to me than dielectric fluid.
Correct. I know.
Putting
it's more
computers
interesting for sure.
Yeah, putting computers inside liquids.
But
yeah,
I got to go back to in our line of business, seeing this technology out there and having an understanding how it works and coincides with the infrastructure that we build and that we create for people and we help design. And I can see a total need for having to have that infrastructure in place.
Well, again, data has to get from point A to point B, and copper's never going to go away, but I know you're seeing it, I'm seeing it, so much fiber is going in. It is
it's everywhere, fiber optics. But what if, I'm just saying, what if scenario, okay?
Yeah.
What if this biological, material comes out that we can take and it's self-repairing and healing like we showed before, and transfer data using biological cells from one place to another.
Right.
Versus fiber optics that we use now. That's a whole new world, a whole new changing system that's out there that, who knows? It's limitless.
Right. I really think that this is a subject we're going to revisit because as it evolves and as things really come to the forefront, I think it's going to be another game changer, just like quantum computing is when it relates to devices and how they operate.
Sure.
And looking for interfaces that are human, kind of acting and adapting and learning based on environment, right?
Yeah.
So this stuff proves that it's adapted to a Pong game in 10 to 15 cycles as opposed to AI with 5,000 cycles, right?
That's fast.
It is. It's exponentially faster and can identify. So therefore, would be able to identify solutions to problems much faster.
Yeah. So put those two together, and we have something
Right.
It could just be amazing, crazy. Who knows where it's going to go, right?
Right.
But I honestly don't feel that it's, like I said before, people are scared. Anything new that comes out there. And that's why we see the issues with Terminator and so forth like that. But the best way to get over that is to face that fear. Learn the technology. Understand the technology. And that's really what people need to do. They need to understand what this is taking place, how it works, so we can understand the benefits. I think the benefits in this case are going to outweigh much more than any of, detrimental scenarios.
Well, again, the idea is just to make, understand it will be coming because technology will be rolling and people will do it. So learning how to put guardrails on it, I think, is really the biggest thing. And, the ethical questions that surround it are yet to be identified and therefore, solved. But, I think it's just so everybody's in the know. That's what we're doing here today is just giving you information, let you sit there and ponder it.
And we didn't even touch on this too. Where do these brain cells come from that they're using in this technology?
Well,
is it stem cells?
Yeah, stem cells.
And are they actual stem cells or are these replicated stem cells? I mean, it goes into a whole ethical scenario, as you can imagine, the path you go down.
Right.
And so I would like to say that take the ethics out of it and look at what a great tool this is going to be.
It's definitely fascinating. That's all I have to say. As Spock would say. Fascinating.
Hey, that little clip from the beginning of the show came from the movie Johnny Mnemonic.
Johnny Mnemonic.
So
not
that's
pneumatic. Yeah, right.
Christopher Reeves? No, who's in that?
No, that's
I'm thinking Superman.
Yeah, I can't think of it right now. I'd have to
Keanu Reeves.
Keanu Reeves.
That's it. If you haven't seen that movie, it's just kind of a fun show. So check it out. So.
All right. Well, we appreciate you being here today. Like, subscribe, and share this podcast. We get into the deep, every Thursday at 3:00. So join us for that adventure. For now, I'm Mark Beach.
I'm John Dotson. Thank you.
Have a